Okay, we are here doing a pretty standard integration by parts sample problem. If you're learning this for the first time, I'm going to try to give you a heads up on a couple things to try to remember to make it easier. Integration by parts is often thought of as being sort of the reverse of the product rule, so it shouldn't be too much of a surprise to see things being multiplied, but it doesn't have to be that way. But what we're going to do is like a double substitution with u and v, and we need to decide what part is going to be our u part and what part is going to be our v part. And I think that it's pretty handy to have a little mnemonic device to help us keep track of this, and it's LIATE. And this sort of ranks in order the primacy of what we're going to choose to make our u, and then the leftover bit will be our dv part. So this stands for logs. Then the inverse trig stuff, then any algebraic expression, then regular trig, and then exponent, okay, exponentials, all right? So as we look at this, how would we classify this? Well, this is just a simple algebraic. This is very clearly a log. There's no trig or inverse trig stuff, but according to LIATE, we are going to go with the log part first. This is going to be our u. So I like this little chart where we put u here and v there and du here and dv here, and we're always going to make our u substitution first, so just kind of get used to filling in this pattern, and I think it makes it a little bit more standardized, a little bit easier. So if this is our substitution, ln of x, okay, then we take the derivative with respect to our variable over here. So what is the derivative of this? It's 1 over x then dx, okay? Now that means that if I've taken care of this, then I've got this part as my dx. So I've got x to the 5th dx. That's going to be, these leftover bits will be my other substitution, and then I'm going to integrate on this side to get to v. Well, when I integrate this with respect to x, I'm going to have 1/6 then x to the 6th. Okay? So we're always going to be going down like that to derive and up like that and integrate, and we'll fill in our two substitutions. Then if you can remember that this is really an expression of our u dv, we know from our little formula that that's going to be u times v, then minus, just do the opposite. If that's a u, then we have a v. If that's a v, then we have du. And that's our little formula. Okay? So now I just fill in with what it is, but always the x part. So u then is ln of x. V is 1/6 x to the 6th minus the integral of then v, which is again 1/6 x to the 6th, and then what is du? Du here is 1 over x dx, okay? And that's what we've got, and then we just grind it out. And so this is, we're just going to maybe make it a little bit more grammatically correct. We often write this out front, x to the 6th ln of x minus, and then 1 over x with x here cancels and gives us 1/6 x to the 5th, okay? Well, I can take that constant and pull it out, so it would be 1/6 out there, okay? And then this would just be x to the 5th, okay? When I integrate this, just like before, I'm going to get 1/6 times 1/6 x to the 6th, all right? And I'm done. I'm just going to write the answer properly. It's going to be 1/6 x to the 6th ln of x, then minus 1 over 36 x to the 6th, okay? And don't forget plus c, all right, like I nearly did. And hopefully that's a nice little example.